Okay, this lesson is on permutations and combinations. And that's really the question behind the question. Is order important? If order is important, it is going to be a permutation every time. If order is not important, it will be a combination. So typically in these kinds of problems. So one way of thinking about permutation when order is important is you can just use this new kind of thing, the factorial command here. So if the question was something like this, something basic, how many different ways can the letters of the word math be arranged in a row? Well, that's an interesting question. So one way of doing this problem, and this may be a long way, but it's a good way to think about it, especially in this developmental stage. Let's try to order those letters in as many different orders as we can. So if I started to write the word math with those letters, so M-A-T-H, M-A, I guess I could say H-T, M-H-A-T. These are all the different ways. M-H, let's see, T-A. M, let's see, I did all the A's and H's, M-T, H-A. And M-T-A-H. So of the ones that start with M, it looks there are 6 four-letter combinations with those letters that start with the letter M. Let me start with the letter A here. So A, M, T-H, A, M, H-T. Try to be systematic when you list this out. This is called the sample space. So when you list out every possibility in probability, it is called the sample space. A, let's see, let's do H, M-T, A, H, T-M. Let's see, I've done the A-Ms and the A-H's, A-T, H-M, and A-T-M-H. So I also happen to get 6 combinations start with A. I'm not going to do the ones that start with, say, T here, but I'm safe to assume there are probably 6 of those. And if I took the time to do the ones that start with H, see, if you do this systematically, oftentimes you see a pattern like, oh, I have 6 M's, 6 A's. I can safely assume this pattern is going to continue. I'm going to have 6 of each type, for a total of, if I add them up, of 24. So there are 24 different ways that you can order the letters of the words be arranged in a row. So by the way, you're ordering the letters. So order is important, so this is a permutation. And we can do a basic permutation with n factorial. So in this case, we have 4 letters. So if I typed in 4 factorial into my calculator, which is the same thing as 4 times 3 times 2 times 1, which is 24, which is the same answer. So we get the same answer either way. So on your calculator, if you, on your calculator, if you hit the, hit 4, and then hit the key down here, I think it has an exclamation point in there as the second choice. 4 factorial, it will automatically do 4 times 3 times 2 times 1, which is the factorial command. If you did 3 factorial, it would do 3 times 2 times 1, which is 6, etc. So I just want you to see that you can type that in your calculator to do that. Okay, in how many ways can a president, vice president, let's see, and secretary be chosen from a class of 9 students? So let's talk about the way we did this yesterday first. So let's do this. I call this kind of the slot method of doing things. So we have 3 choices to make. You are going to try to elect a president, vice president, and a secretary. So this is president. This is the vice president position and the secretary position. And we're going to multiply those numbers together, kind of using the counting principle. And so those numbers would be, let's see, how many different ways, how many different people could be voted for president? There are 9 students. There could be any of those 9 have a chance at president. Once you've chosen the president, these events are occurring in order here. So now we only have 8 choices for VP, so that would be an 8. Once you've chosen the president and VP, there are only 7 choices left. and whatever 9 times 8 times 7, I'm guessing 504, would be the total number of ways that you could elect 3 positions to a class of 9 students. So now this is the official way of using a permutation. So order is important, so you could use a permutation for this. It's a little fancier than just n factorial. In fact, there's a whole formula right here. I do not need you to memorize this formula. I do need you to be familiar with this form, this NPR formula. That's not National Public Radio. That is, the P there stands for permutation. And in your calculator, it might look something similar to this, like NPR parentheses n comma r. So we're going to use the formula to solve this. So in this formula, so n is the, think of n as like the, what, n objects. How many objects? How many total objects are there? There are, so there are 9 different people in this class, so n is 9. And then r is how many I'm choosing or taking at a time here. So r would be equal to 3. I have 3 positions I'm trying to fill. So I've got 9 total people, but only 3 of them get positions. So this would be, n would be 9, so this would be 9 factorial. The way to write 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then the denominator is going to be n minus r. Well, n minus r is 9 minus 3. 9 minus 3 is 6. So 6 factorial down here would be 6 times 5 times 4 times 3 times 2 times 1. So if we cancel out here, we see that the 6's cancel, the 5's cancel, the 4's, the 3's, the 2's, and 1 over 1 is just 1. We're left with 9 times 8 times 7, which is the same problem we got up here. So this is kind of a formulaic way of doing it. On the calculator, the way you do that is you hit the menu key on TI Inspire. This looks like a probability. That's the name of the chapter. And this is a permutation. When order is important, it is a permutation. It automatically types in NPR. We just put the n, comma, right down here in the bottom left, r, which is 3. And so we get the same answer, 504. So it does, basically what the calculator is doing, it's doing this formula every time you type in NPR, it's typing in that formula for you. So it just does a little bit of that work for us to do it. The question behind the question, is order important? That's really what you're asking. For 20 raffle tickets and a hat, 4 tickets are to be selected in order. The holder of the first ticket wins a car, the second a motorcycle, the third a bicycle, and the fourth a skateboard. How many different ways can these prizes be awarded? Is order important? Order is important. So if order is important, you can do this problem 2 different ways, the slot method or using a permutation like NPR. So let's try it the slot method way. So we have, it looks like we're making 4 choices here. There's 4 prizes. The car is first, and so that would be 20 different people that have the option of doing that. Next is the second is a motorcycle, so 19. And the third is a bicycle, which is 18, and fourth is skateboard, 17. So after you give away 1 prize, it determines that, multiply that in your calculator, you get an answer. If you do this the other way, we're going to use the NPR, so NPR way of doing this thing, because it should work as well. So doing it that way, you get out your calculator, menu, probability, to permutation, order is important, and so this would be, let's look back at the question, 20, choose 4, right? So 20 objects taken R at a time, taken 4 at a time, so we're taking 4 at a time, so 24 is 116,280, and so you get the same thing as if you had multiplied here, you get 116,280. That's quite a lot. So this is one of the toughest to identify until you get used to it. And then it's maybe obvious, but it takes a while. So this is a distinguishable permutation. So this is it is a permutation. Order is important, but it's a little tougher. It's almost like a combination of order is important and it's not important. In some ways it is important, in some ways it's not. So we call this distinguishable permutations. Let's say you were taking all the permutations of the letters DAD, D-A-D. So let's just write down all the different ways you could spell DAD. Don't worry so much about capital letters here. So D-A-D. let's see, D, all the different permutations. So D, DA, ADD, sometimes ADD when you're dad. Okay, so an A, well, is that it? See, here's the problem, right? So you've got like, is DDA, what if I put this D and put it first? DDA, right? Like DDA, is that any different than DDA? No, that's not really any different. What about ADD? What if I switched these two Ds and I wrote it as ADD? No, like those are the same, right? There's no reason to write that. There are only 3 different ways of writing out this answer. So to do this right, what you have to do is plug in your n. So the numerator is easy. There's 3 letters here, so it would be 3 factorial. The denominator is all the different groupings. So I have 1a, so that would be 1 factorial. And then I have another group of, I have 2d's, so this would be 2 factorial. So this ends up being 3, you can type that in your calculator if you want, times 2 times 1, over 1 times, let's see, this is 2 times 1. And you can see that the 2's cancel, and you're left with 3 over 1, which is 3, which is the same answer. So you get the same answer doing this way, just a little bit tougher. Basically, these are all the grouped categories there, because we have no way to distinguish between ADD and ADD. Sounds like the same exact thing. So it's not a distinguishable permutation, right? So we need to be able to distinguish between the two. Okay, let's try another one. So let me make sure something here. Okay, let's do one more on this one. I thought there was another one. So let's find the number of ways of pitching 15 balls in a row, given that 4 are red, 3 are green, 6 are orange, and 2 are blue. So this is different than just 15 factorial because we have different colors, and we can't distinguish. What if you put 2 reds together? Well, they look the same. So I think this is going to be a distinguishable permutation, 15 factorial over, let's group all the different colors together in the denominator. So we have 4 factorial here for red, 3 factorial for green, 6 factorial for orange, and 2 factorial for blue. And we type that in our calculator just like that, and we'll get an answer. And I'm not going to do that work for you. That's the idea. The hardest part is identifying the distinguishable permutations. Combination is when order is not important, right? And so we have this idea of this formula. It's just a little bit different. It has this r factorial in it as well. Club has 9 members. How many ways can a committee? So a committee of 3, it doesn't really matter who's selected first to the committee or second to the committee. And so you cannot use slot method. Do not use slot method. That's only when order is important. You have to use NCR. So NCR, in this case, NCR N would be 9, and R would be 3, just like we had before, but now we have this extra value there. So I would just get a calculator at this point. Menu, probability, combination, because order is not important here, and 9, 3. And we get 84, a lot less than, if you remember, NPR was 504 ways. There are only 84 ways when order is not important. There's 84 different ways of doing this. 20 raffle tickets in a hat, 4 tickets to be chosen at random. The holders are rewarded free trips to the Bahamas. And how many ways can the 4 winners be chosen? Is order important? I just want to be selected. I don't care the order that happens. So this would be an NPR in your calculator, and you would type in 20 is your n, comma 4 is how many you're selecting. And again, you cannot use a slot method for this one. Order is not important. Doesn't matter which ones you're selected. Type that in your calculator, you'll get an answer for that. We'll wait on that last one. By the way, just as a side note, if you watch The Bachelor with the rose ceremony, is that a permutation or a combination? Is order important or not? If you get a rose, you advance to the next round. And so I would say that's a combination. Order is not important. It doesn't matter if you're first or last. If you get a rose, you advance to the next round. I just thought you might like that example. That's the end of the lesson.